Grissom remained directly involved with the Gemini program for quite some time, including several months of training as backup commander for the Gemini 6 mission. At the same time, work on the Apollo spacecraft was already well in progress. In March 1966, NASA publicly announced that Gus Grissom had been assigned as commander for the first Apollo Earth orbit mission. Ed White would serve as senior pilot, and Roger Chaffee was named pilot. Jim McDivitt, David Scott and Russell Schweikart were assigned as backups. By the time Gus was freed up from his duties on Project Gemini to jump aboard the Apollo program, the spacecraft and its systems were well advanced in terms of production and testing. Unlike Gemini, Grissom and his crew inherited a spacecraft that had been designed for them, but not with them. Although they did not have a hand in the basic design process, Grissom and his crew were able to exert some influence on Spacecraft 012, which was scheduled for an October 1966 launch. He and Ed White and Roger Chaffee, along with their supporting staff of engineers and technicians, participated directly in the progressive design and manufacturing reviews and inspections as Spacecraft 012 neared completion. Some of the things Gus saw he did not like. As the pressure mounted and dissatisfaction grew, Grissom for the first time began to bring his work problems home. When he was home, he normally did not want to be with the space program. He would rather just be messing around with the kids, but now he was uptight about it. The arrival of Spacecraft 012 to the Cape only brought more problems. It soon became obvious that many designated engineering changes were incomplete. The environmental control unit leaked like a sieve and needed to be removed from the module. As a result, the launch schedule was delayed by several weeks. The Apollo simulator, which was used for training purposes, had its own set of problems and was not in any better shape than the actual spacecraft itself. According to astronaut Walter Cunningham, we knew that the spacecraft was, in poor shape relative to what it ought to be. We felt that we could fly it, but let's face it, it just wasn't as good as it should have been for the job of flying the first manned Apollo mission. Nonetheless, the crew made do with what they had, and by mid-January of 1967, preparations were being made for the final pre-flight tests of Spacecraft 012.
In the afternoon of January 27, 1967, the three astronauts entered their spacecraft and were sealed inside. Instead of a sea-level pressure nitrogen-oxygen atmosphere, as the Russians had used in their Vostok, Voshchod and Soyuz capsules, the Apollo 1 spacecraft used a 100% oxygen atmosphere. What was the cabin air pressure? Well, it was... Well, nobody really knows. As Ralph Renee has managed to establish, there has been some great dispute among the astronauts as to what the actual pressure was inside that spacecraft. In Carrying the Fire, Michael Collins claims the pressure was nearly 16 pounds per square inch, whereas Gordon Cooper of Phase 7 and Gemini 5 states it was 16.7 psi. In the documentary released by Nova entitled To the Moon, Apollo flight director Christopher Kraft claims the pressure was only 15 psi.
We had 15 psi of pure oxygen in that spacecraft. And at 15 psi of oxygen, aluminum burns.
And finally, Frank Borman of Gemini 7 and Apollo 8, the expert of thermodynamics, puts the pressure at 20.2 psi, what he goes on to call
an extremely dangerous environment, the equivalent to sitting on a live bomb, waiting for someone to ignite the fuse.
The company in charge of building the command module was North American Aviation. It became Harrison Storms' pet project. On pages 224 and 225 of his autobiography, Angle of Attack, written by Michael Gray, we find,
after the hatch was sealed, the cockpit cabin was pressurized with pure oxygen as it would be on the way to the moon. Since this spacecraft was designed to contain pressure in the vacuum of space, not resisted from the outside, and since the sea level pressure would be somewhere around 14.7 pounds per square inch, the cabin was pressurized to 16 pounds per square inch. Unfortunately, this fact was simply the end result of a string of logical decisions, and and not something that anyone had planned for. The engineering specifications speak only of a 5-pound oxygen environment, and neither Storms, nor Charlie Phelps, nor anyone else in top management had any idea that there were 3 men sitting inside the command module, surrounded by pure oxygen at 16 pounds per square inch. If Toby Friedman had discovered it, he would have grabbed the phone and screamed at them to hold everything. Toby was a doctor, and every doctor knows of hospital stories involving oxygen fires. True, Toby had signed off on the idea of pure oxygen and the command module, but only at NASA's insistence, and then he was under the impression that they were talking about oxygen at 5 pounds per square inch. At 5 pounds, the pressure inside the command module in orbit, a lighted cigarette would merely burn rapidly. At 16 pounds, the cigarette would vanish in a flash along with all your hair and your clothes as well.
What North American Aviation is claiming is that no one within their department knew the pressure the Apollo 1 crew were sitting in until after they learned of the terrible tragedy. This is not what they told us 3 years before the fire. In the July-August 1964 Journal of Spacecraft and Rockets, Dr. Frank J. Hendel put in an article entitled Gaseous Environment During Space Missions. At the time, Dr. Hendel was a staff scientist from North American Aviation. He was part of the Apollo project. On page 361, Dr. Hendel had this to say about a 100% oxygen atmosphere.
It presents a fire hazard, which is especially great on the launching pad when the cabin is purged with oxygen at 14.7 psia. Even a small fire creates toxic products of combustion, hence fire prevention measures and/or firefighting equipment aren't mandatory. However, no firefighting methods have yet been developed that can cope with a fire in pure oxygen.
Why do Harrison Storms, Charlie Phelps, and Toby Freeman all claim they thought NASA was doing a test at 5 psi when as early as 1964, one of their engineers clearly knew NASA does these tests at sea level pressure? And just how could anyone within top management possibly have made that mistake? North American Aviation had hundreds of guys working on the pad that day, so they clearly knew NASA was doing the test on the pad. During the fire, the capsule ruptured when the pressure inside Apollo 1 rose to 29 psi.
At 6:31:17, or 14 seconds after the fire had first been detected, the cabin pressure reached a level of about 29 pounds a square inch, and the cabin ruptured.
That's 8.8 psi over the 20.2 psi that Frank Borman claims was inside the capsule. This means the capsule cannot withstand an outward pressure of 8.8 psi. Doing the test at 5 psi on the launch pad would have been impossible, because the external pressure surrounding the capsule is 14.7 psi. If the cabin pressure was reduced to 5 psi, that would have created an inward pressure difference of 9.7 psi. This inward 9.7 psi would have instantly crushed the spacecraft. The craft was not built to withstand an inward pressure, and doing so is very difficult, as this experiment with a soft drink can shows.
Without air or water vapor, the can will be almost empty, very little pressure. The air pressure around it will then crush the can very quickly. Pretty cool, huh? Want to see it again? Okay. So the pressure of the air around us crushed that can.
The only way they could have done the test at 5 psi would be to place the spacecraft inside a large vacuum chamber. Anyone with the most basic understanding of aerospace engineering knows that to simulate the 5 psi conditions on the ground with the external pressure surrounding the spacecraft, you would need to go above that external pressure. In this case, 16.7 psi. Or was that 20.2 psi? Actually, to accurately test the 5 psi conditions on the ground, you need to raise the internal pressure up to 19.7 psi. because 19.7 psi is 5 pounds above the normal sea level pressure. Either way, how could NAA possibly have assumed that NASA was doing this test at 5 psi when they had hundreds of their own guys working on the pad that day, and their own Frank Hendel clearly stated in 1964 that he knew the pressure NASA used in these tests?